Hello everyone, welcome back to another video. So today we will discuss editorial for weekly contest 400 and I solved all four problems. So we will discuss all four problems. Let's start with first problem. So in this question we are given a string and we have to simulate this type of situation for every I, and I represents a second. So if s of I is e, that means a person is entering the waiting room and takes one chair in the waiting room, and s of I equal to l, that means a person leaves the waiting room freeing up a chair. So we have to return minimum number of chairs so that a chair is available for every person who enters the waiting room. So let's say e, and l, that means a person 1 is entering and the answer for this case would be 2. Now if we fix, let's say, 2 seats in waiting room, person this person comes and sits on this chair, and this person comes and sits on second chair, and when a person leaves, let's say this person leaves and this is now free. So in two chairs we satisfy the condition. Now if we have put if there was only one chair, the first person comes and sits on the chair. Now when second person comes, there is no free chair for that person, so 1 cannot be the answer, and 2 can be the answer. Similarly 3, 4 up to infinity, uh, all these can be answers, but we have to find minimum, so minimum in this case would be 2. Now as constraints are low, you can write brute force for it. So brute force can be iterate from 1 to 50, and for each answer check if the condition is satisfying or not. And how to check that? You can just keep counter of chairs, number of chairs filled. So whenever e is there, you add 1 to the number of chairs occupied, and whenever l is there, you subtract it. Now while occupying, if let's say the number of chairs already occupied are equal to the whatever I fixed, which was fixed at start, then that I cannot be the answer. So you have to check for all values from 1 to 50 and find the answer. So that is brute force. Another way to do is find maximum number of chairs, occupied chairs, at every second. For example, e e e l, let's say this is e again, this is e, and this is l. Now at first there will be one chair occupied, at second 2 there will be 2, at second 3 1 will be freed, so number of chairs occupied becomes 1 again, at second 4 2 occupied, at second 5 3 occupied, and at second 6 2 occupied. So what is the maximum number of chairs occupied at 1 second? At any of the second it is 3, so answer should be 3, because to satisfy that condition we must have 3 chairs, and all other times the number of occupied chairs will always be less than equal to that max. So answer, this greedy type solution also works. So let's see the code for that greedy type solution. So I have declared two variables, answer and c. So answer is global maximum, c is current number of chairs occupied. Now if I will add 1 if the s of I is e, I will subtract 1 if s of I is l, and take max of it with answer and just return answer. So this was first question, pretty simple. Brute force also works. Even binary set can work, but that is not necessary. O of n solution is simpler. Now second question, this is kind of annoying question, I would say. So in this question we are given days representing total number of days of an employee available to work, and you are also given 2D meeting array meetings where meetings of I starts at start I and ends at end I, and we have to count the number of days when employees available for work but no meetings are scheduled. So that means in this case, as you can see, 1 to 3 there is meeting, 5 to 7 there is meeting, and 9 to 10 there is meeting. But at 4th and 8th day there is no meeting. So the number of days when employees available when it is free, that means there are no meeting scheduled, is 2. Similarly, in this case, 1 to 3 and 2 to 4 are meeting. So 1 to 4 are meeting, but on 5th day he is free, so answer is 1. And in this case answer is 0 because there is no time. There is not a single day where there is no meeting. So there would be a sorting solution here where you sort them by first when you sort them by starting times of meetings, but I implemented a sweep line solution. So what sweep line is, whenever you start meeting you add +1 to that index. If the constant of days would be 10 raised to power 5, then I would have implemented normal vector, but it is 10 raised to power 9, so I have to use a map. So let's say I have to represent that there was a meeting starting at 1 and which was ending at 3. So by brute force I can obviously add 1, 2, 3 as booked or mark them as booked. So brute force what I can do is I can just mark them 1, 1, 1. So this is brute force. Now second way of doing it is you add 1 at start of that meeting and subtract 1 at end +1 time. Now when you take prefix sum of this, it would come out to be 1, 1, 1 and 0 as we wanted in our brute force. It will be similar to it, but the operation required for each query would be O of 1, and overall summation would be taken once after all the queries are processed, and that would be O of n because it's just prefix sum. Now it would work in vector, but the constraints are 1 in 9, so you have to use map. And in map, while performing sweep line, you have to store previous 0 which was occurred. So what previous 0 means, let's say at 6 this prefix sum is becoming again positive. Now if I have the previous 0 at 4th position, that means I can say that 4 and 5 was the free employee was free on 4th and 5th day, so I can add 6 minus 4 to my answer. So basically this 4 represents the previous 0 which was occurred, and 6 represents the first positive prefix sum which occurred after an occurrence of 0. So let's see the code for better understanding. So I have declared a map and I am adding MP of C of 0 plus plus and decreasing C of 1 plus 1 means end plus 1 I am decrementing. Then I am taking some answer and previous of 1. So this previous one represents the first element which was. So we have also need to consider if the starting of meeting is itself from 2, then first day the employee was free. So to consider that condition, I have declared it as 1. Now I will iterate over map. This is an ordered map, so it will iterate in sorted order, and I'm adding c dot second. Now if sum becomes greater than 0 and previous is not equal to -1, that means we have found 1 0 previously, then I will add c dot first minus prv in my answer. So this simulation of this condition 6 minus 4, and make prv equal to -1, because there might be continuous positives and I don't have to consider it again and again. Now else what I would do is I will add else I would, if sum equal to 0, else I would just update prv with c dot first, and finally I will just add d minus prv plus 1. So last condition, let's say meeting ends at, all meetings end at 8 but the working days are 10, so I have to add 10 this and this, 10 and 9 to my answer. So for that, this condition, and finally I'm just returning this answer. So this was, I would say, annoying question. There might be a better approach for this. I can just count where sum is greater than 0, and just subtract d plus 1 d minus that count. That also can be done, but I just implemented this question. I implemented this solution as it came to my mind first. Now third question. This was also, I would say, STL based question, not so difficult, but you just need to find the optimal remover of character. Now we are given a string s and it may contain asterisk characters, and we have to remove all this star characters. And how to remove that? So if there is a star, we have to delete the leftmost star and smallest non-star character which is to its left, and if there are several characters you can delete any of them, and we have to return smallest resulting string after removing all those star characters. So for example, in this case a star. Now before star, the smallest non-star character is a. Now we have three options of removing a. First, the character at index 0, character at index 1, and character at index 3. We removed 3 because removing 2 or 1 will make the string lexicographically higher than the removing third index character, which is AAB. If we remove this A, the string would be ABA, which is lexicographically higher, lexicographically greater than this AAB string. And in this case ABC, there is no asterisk star, so we just return ABC. Now how to do this is a greedy type of approach. Let's say I am at I get this star at position index 4. Now at this stage, what I should have is details of all the characters before it. Now what type of details I would require here? Indexes of index vector of all characters. That means A would be mapped with its index 0, B would be mapped with its index vector of its indices, C would be again its up to Z. Now I can iterate for each position. I can iterate into all 26 characters and find the smallest character which has remaining indexes greater than 0. Means, for example, there is a index for A, so I should find the minimum possible character, that is A, and then remove one index from that set of indices. Now which index to remove? Let's say, let's just take the sample test case. Now for this star I have these options. Now it can be proved that always removing the rightmost character before star of that smallest character is optimal, because if you remove this, there are chances that there is a higher character to its right, which will replace this character with which has higher order in alphabet. For example, this A will get replaced by this P, and which will make this string lexicographically greater. What we want is lexicography smallest. So it can be proved that it is always optimal to remove the rightmost character before star. Now how do we simulate this in code? It would be difficult. Now to simulate this, I have used two maps. One is just normal int to int map. Second is character to stack. Now stack is used to store indexes of that character. Now I will iterate over string, and if current character at index I is star, I will explain this later. Else if it is not star, I will just push that index to s of I. Now if it is star, what I will do is mark that index with 1, and I will iterate from A to Z, and if any of the stack size of any character is greater than 0, that means I found that ch is, if it enters this condition, that means ch is the minimum character which has to be removed. Now we have to remove rightmost character, so the stack's top value will represent its recent most index. So I will mark it as 1, and then pop the index and break. We have to remove only one character, so I am breaking here. Now why I mark this indexes? So I mark them because I have removed them from string. So after that I have declared an answer string, and if I don't find index I in my map, that means it was never marked, and I will just add that as a character in my answer and finally return the answer. Again, there was two simple observations: how to store this data before that asterisk, and which character is important to remove, the leftmost character or the rightmost character before asterisk. And it can be easily understandable why this sample disk is also, because always the removal will be uniform, means the optimal solution, optimal removal will not be depend on any other condition than just the rightmost character before asterisk. So this was third question. Now we'll move to fourth. This is also a standard type of question, I would say. So we are given an array of array nums and integer k, and we have to find subarray nums such that absolute difference between k and the bitwise and of all subarray elements is as small as possible. So we have to find a subarray such that absolute difference between k and of that subarray is minimum, and we have to return that minimum possible value. For example, let's say this is my array and k is 3. Now nums of 2 and 3 has a value 4. So this 4 and 5 is 4, and which gives minimum absolute difference as k minus 4 is 1, and there cannot be any other minimum value. Similarly, in this case, the AND value of this 2 with itself, this subarray of length 1 and 2 minus 2 is 0. Now in this case there is only one option, that is take 1 itself, and 10 minus 1 would be 9. Now first observation, it is not an observation but a general property of AND, that it is AND is decreasing. That means, let's say I have an element A and I take new AND as A and B. Now what I can say is that new AND value will always be less than equal to A, because AND in bitwise representation, this 0 will always remain this 0 again. This one has a probability to this one can become 1 or 0, this one can become 1 or 0, this one can become 1 or 0. So there is no gain in addition of there is no gain while taking AND. There is a probability of loss or equal, the bit remains same as it is. So the AND will always decrease, all remain the same. So this property of monotonicity is important to solve this question. Now second observation would be, let's say I have 5 and I have to find a element in this let's say I have 5 and I have a sorted array. Now I have to find an element such that the absolute difference of this 5 and any element in this array is minimum. Now to find this, obviously there is an O(n) solution, brute force solution, but we can also solve this with log n. How is that? So minimum absolute difference between this 5 and any element would be minimum when that element is less than 5, last element which is less than 5, and first element which is greater than equal to r, which is greater than 5. So for 5, those numbers would be 4 and 7, because there is no point in comparing it with 2, because 5 and 4 itself gives minimum answer. Now if you try to compare it with 5 and 2, it would be 3, which is greater than its right element, so no need to go further before that 4. Similarly 7 and 5 would give 2, but no need to go beyond this, because it would increase the difference, and as we want minimum, it can be either this element or this element. So what we have to do, first we have to find the element which is greater than 5. As you see, it would be 7, and then subtract that index, and it would be less than equal to 5, and that would be my L, and first IDX will represent the R. So we have L and R, then we just check minimum absolute difference from both of them. I hope you understand this, how we can find it in log n. We have to find the upper bound of 5, which is 7, and then take the previous element, which is 4, and take a minimum absolute difference from for both the elements. Now how would we implement this? Now moving back to our question, let's say I fix I. Now from I am taking and of its elements with its previous all elements. So first I at I it would be a of I, then of for I minus 1 it would be ai, and a of I minus 1 at I minus 2 would be ai, and a of I minus 1 and a of I minus 2. So this would be decreasing in this direction, right? Because taking and would be is monotonic and decreases as we add more elements to our and. So in this decreasing array we have to find first rightmost element which has and greater than equal to k. Let's say it was I minus 2, and the leftmost character to it. We will first find strictly greater than k, the leftmost character which has and strictly greater than k, and the element to which is present at its left would give and which is less than equal to k. So we got, as we have discussed, this element and this element. So first we got the element which has and of all consecutive all consecutive elements from that to I, which is strictly greater than k, and from this index we can also find the greatest and, but it's less than or equal to k. Now we have to take minimum of these two indexes and update our global result from minimum of both of them. Now how to store this and in logarithmic or constant time complexity. So for that we have to use segment tree, because you cannot iterate just from I to leftmost character using of an operation. The solution would be of n square. Now how to find this upper bound? You can use we have to use binary search to fix the middle element and apply binary search on answer for finding first the leftmost index which has and till I greater than k. And for each query we have to just get this from segment tree. Now let me explain the code. So this whole part is segment tree. Now you can copy this from my github cp template. I have a repo called as my cp templates, where there is segment tree, sparse table, and lazy propagation template. You can use that. It is probably the easiest way to implement segment tree, because I have not used any type of complex class or structure. And now what I'm doing is, first I'm building the segment tree, then I have declared a result variable with int max. Now I will iterate from I to 0 to n, where I am fixing the rightmost or fixing the end of the subarray, end of my subarray. Now if a of I itself is less than equal to k, there is no possibility of finding an element which has and greater than k, because and is always decreasing. We cannot increase and. So in that case I'm just taking minimum with k minus a of I, and else I'm running a binary search for finding the index which has leftmost index which has and greater than k. Now how to find this? I have declared low with 0 and high as 1, high as I, and I have also declared an answer variable to store that index. Now I am finding mid and taking and from that middle index to I. So let's say I am at this position and I is there. First of all, this mid will be called, and after this mid I'm calling a query for this part, this segment. If this and is greater than k, what I will do is I will make this high equal to md minus 1. So, and also update my answer to this md, because there is a possible chance that there are no more elements which have no more indexes which have this segment and greater than k, and if there are, they will be update, the answer will get updated after, in later binary search calls. Now if it is less than equal to k, that means the segment should be more smaller, so I will update this low to md plus 1, and then binary search will be called on this segment. So first I'm if d is less than equal to k, updating the md and making high equal to md minus 1. It would not be a problem if I just make this equal to, because even if it is equal to, then even if I make it greater than k, the previous element would be equal to k. So both conditions are okay. Then I have found answer which is storing the leftmost element which has greater than or equal to k, and then I'm taking that and taking its minimum with my global result with absolute difference of k minus d. Similarly, I have to check if the previous element of that answer index, first of all it should be greater than equal to 0, and then I'm just again taking its and just taking absolute difference with k. So this was fourth question. I think segment trees standard question is with binary search, I would say. So this was not so difficult. You just have to you must know some properties of and you will solve this. And all questions were easy. First 4. Second was bit annoying. I made one penalty on second and 2 penalties on fourth. So yeah, that's it from my side, and thank you for watching.